Hello, Chemistry 12. This is a lesson on balancing half reactions. Okay, so it's actually a fairly short lesson and it's fairly straightforward. So it shouldn't take you too much time. Now, we've been introduced to half reactions before. And remember we had the, we had the standard reduction potential table. Okay, so you were given this, okay? And these are half reactions. And these are already balanced for you. But what if this is not all of the half reactions that can occur in reality? So sometimes if we can't find it here on the standard reduction potential table, we have to sort of balance it ourselves. Okay? So for balancing half reactions, sometimes a half reaction is not found on the data table. Therefore, we need to balance the reaction manually in acidic or basic solutions. Now, the general rule is something called balanced major hydroxide. Okay, so what does it represent? So each of these represents something. So this represents number 1. The oxygen is number 2. H is number 3. And the -1 is number 4. Okay, so where does this 1, 2, 3, 4 come from? It's right here. So to balance, number 1 is you want to balance the major species. Now, the major species is everything except hydrogens or oxygens. Okay? Now, why is it balancing everything except hydrogens and oxygens? Is because the oxygens are balanced out in step number 2, and the hydrogens are balanced out in step number 3. Okay? Now, there is a 3a. It says for balancing half reactions in a basic solution, add equal numbers of OH on both sides of the reaction to cancel out the H plus and form water. And for step number 4, it's balance the charges by adding electrons. Now, what do I mean by this? So let's say we take a look here. Okay, so let's say, for example, let's have Cl2 gives you ClO4 minus 1, and it's in acidic solution. Okay, now, so what we do is we do the 4 steps. Okay, so step number 1 is we balance out the major species. So in this case, the major species is chlorine. So we have Cl2, okay, Cl2. And what you have is, again, my pen is running out of ink. Haha, get it. Okay, so here we have, come on, ayah. Sorry about this. I think it's just the connection. It's sort of wonky. It was working fine, but maybe this computer is old like me, so it takes a little bit of a restart. So what we have is we have ClO4 minus 1, but now we have to put a 2 in front of it because we have to balance out the chlorines. All right, now step number 2, we balance out the oxygens. So what we have is we have Cl2 and we have 2 ClO4 minus 1. And on the left-hand side, what we have to add is we have to add 8 waters. Why are we adding 8 waters? Is because we want to balance out the oxygens. There are 8 oxygens in total on the right-hand side because we have 2 ClO4s. So we need to add 8 waters to balance out the oxygens. Now what we do next in step number 3 is we balance out the hydrogens. So we have Cl2 plus 8 H2O, gives you 2 ClO4 minus 1s. And now what we do is we add 16H pluses on the right-hand side. Now, why do we add 16H pluses? Again, because of the fact that you have 8 waters on the left-hand side. So since you have 8 H2Os, you need 16H plus on the right-hand side to balance them out. Now, for step number 4, we balance out the charges. Now, before we do that, what I do is I take a look here. Here I have a charge of 0. Here I have a charge of plus 14. Now, how did I get the plus 14? We have the 16H pluses, which is plus 16. And then since we have 2 ClO4, each of them are a minus 1. That's why we have an overall charge of plus 14. Okay, and I'll call this net. So net charge. So in this case, I need to make sure that the charges are the same. So here, what I would need to do is I would need to put my electrons on the right-hand side. So step number 4, we have Cl2 plus 8 H2O. I would go 2 ClO4 minus 1 and 16 H pluses. And in this case, I would add another 14 electrons. Now, why would I add 14 electrons? Because again, if I look here, the net charge is equal to 0. And in this case, if I add everything up here, also a net charge is equal to 0. Okay? And now I know this half reaction is balanced. Now, it's in an acidic solution, so makes sense. So here I have acid, so I should have H plus in my products. And in this case, I know it is oxidation because, again, look at the location of the electrons. In this case, it is in the products. As a result, what you have is you have oxidation because electrons are produced. Okay? Now, these 4 steps are pretty straightforward. Now, you might say, Mr. Chan, what about the 3A? It says a basic solution. So what do you do? Okay? So what I want to do is I want to go through the basic solution. Okay? Let me give you another example. So let's say we have Cr2O7 minus 2 gives you Cr plus 3. Now, this is in a basic solution. Okay? Now, if we follow steps 1, 2, and 3, so if we do steps numbers 1 to 3, what you should be able to see is I have this. So I have Cr2O7 minus 2, and then we have, oh, whoopsie. Yeah. So sorry. Okay. And if we go all the way, you should have, nuts. Come on. You should have plus, come on, pen. Why aren't you working? So sorry, folks. If you can finish this off, that would be great. Okay, so I'm just trying to get a new battery, or just hopefully this battery will keep on lasting till the end of COVID-19. Okay, you can fast forward through this if you want. Okay, plus, what have I got? 14 H pluses here. Gives you 2 Cr plus 3 plus 7 H2Os. Okay? Now, you have this. Okay? So that's like what we had done in step 3. We've got our waters, we've got our hydrogens. Now, because it is basic, this is where we have to start with step number 3A, where it is basic. Okay? So in this case, what we have to do to both sides is we need to add 14 OHs, OH minus 1. Okay. I should get new batteries for this or do this another time. Okay, I apologize. Okay, so 14 OH minus 1 to both sides. Okay, now what's the significance of this is that it neutralizes the H plus. Okay, so if we were to balance this out afterwards, so here, this would be Cr2O7 minus 2 and 14 waters would give you 2 Cr plus 3 plus 7 waters and plus 14 OH minus 1. Now, again, afterwards, what you can do is take a look at the net charge. Here, the net charge is equal to minus 2. Here, the net charge is equal to minus 8. So in this case, I need to bring the left side down a little bit more. So here, for step number 4, it would be Cr2O7 minus 2 plus 14 H2O plus 6 electrons gives you 2 Cr plus 3 plus 7 waters and 14 OH minus 1. So if we look at the net charge on both sides, here, this is a net of minus 8. Here is a net of also minus 8. We are good. Okay, now it is basic. So this is, you notice, let me put it into a different color pen so you can see it. You have OH minus 1, which makes sure that it is basic. Now, this is fine, but what you can do is you can clean it up a little bit by, notice that there's water here on the reactants, water on the products. So you eliminate this water, this one reduces down to 7. Okay. So that is balancing half reactions in basic and acidic solutions. Okay, so notice the first 3 steps are the same. It's just that for the basic, we just have to add an extra step in terms of adding OH minus 1. Okay. Okay, ooh, I am very dim. Okay, so hopefully, look, I'm brightening up. Okay, so hopefully that is been a pretty straightforward lesson. Okay, so I'll go over any problems you have with the homework next day. All right, thank you very much. Have a good day. Bye-bye.